Welcome back to the video for lesson 2.2. This lesson is kind of random in a way because it doesn't really have to do with functions or linear equations, but it does have some pieces that we're going to need for later on in the semester. So the first thing we're going to look at is we're going to learn how to use the distance formula to find the distance between 2 points, which is helpful if you're dealing with triangles or lines in general. So using the Pythagorean theorem that says if you have a right triangle, which we do, this would be our hypotenuse, that we know that a squared plus b squared, which would be the two sides, each of them squared, is equal to the hypotenuse squared. And so the side C, the hypotenuse, is equal then to the square root of the sum of those side lengths squared, which is the same as finding the distance between these 2 points. So we just need to know the distance from this point to from point C to point A, and then also the distance from point C to point B, and we can find the distance between B and C, which is diagonal. So we can use this formula here between 2 coordinate points. So we're going to find the distance horizontally between the x's and square that distance, and then we're going to add the square of the distance of the vertical values on the coordinates. So let's look at example 1. We have the point 1, 2. Let's just plot these points so we can see where they are on the x and the y. So 1 and 2. And then a -4, 7. So here's 0, 0. So 1, 2, 3, 4, and then 7. 1, 2, 3, 4, 5, 6, 7. So we want to know the distance here between these 2 points. So we're going to find the distance here and the distance here. And we take the square of the addition of these and take the square root. So if we use the distance formula, we can say 1 subtracting a -4 squared plus 2 subtracting 7 squared. So the distance equals the square root of, we have to add those, so that would be 5 squared plus 2 minus 7 is a -5 squared. So the square root of 25 plus 25 is not 25. We have to add them first. So the square root of 50, which is not a perfect square root. The square root of 49 is 7. So it's just a little bit bigger than 7. So I think it's like 7.1. And we can look at that in Desmos in a little bit. And if we look here, we can also find the midpoint of a line segment. So the very middle of 2 points. So looking at those same 2 points, we can find the midpoint between them by taking the average of their x's as the y coordinate and the average of the y's as the y coordinate. So the average of the x's for the x coordinate. So 1 plus a -4 divided by 2. And then 2 plus 7 divided by 2. So that becomes a -3/2, comma, 9 divided by 2. Which is the same as a -1.5, comma, 4.5. Is the midpoint. If we were to look at that on the graph between these 2 points, it would be at a -1.5. So right about here and right about there. let's find the distance and the midpoint between these 2 points. So the distance formula says we're going to find the difference between the x's, a -4 subtracting a -10 squared, plus the difference between the y's squared. That becomes a -4 plus 10 squared, and then 6 squared. So -4 plus 10 is 6 squared plus 6 squared is the square root of plus 36 plus 36 is a square root of 72. And that is not a perfect square root either. We could break it up into the square root of 36 times the square root of 2. And the square root of 36 is 6. So it's 6 times the square root of 2. So it's just over 6. And the midpoint between the same 2 coordinate points is going to be a -4 plus a -10 divided by 2, and 20 plus 14 divided by 2. So a -14 divided by 2 and 34 divided by 2. So -7 and 17 is the coordinate. The last topic of this lesson, we're going to bring in circles and equations of circles. And we're going to talk about circles in chapters 5, 4, and 5, and 6, a little bit in 6. When we start introducing the trigonometric functions. And so they're introducing the basics of the circle now. So a circle has a center, and the radius is the distance from the center to any point outside on the circle, and it's the same between all of those. And so we have the radius here, and then the diameter is the distance all the way across through the center. So this is a circle at center 0, 0. The one down below is a circle with a center at H and K. So it's just off kilter. It's not at the origin. We're going to look at both. So the circle with center at 0, 0 and radius r is a set of all points x, y satisfying this equation. X squared plus y squared equals r squared. Because it's not off center at all from the origin, there is no distance. X is x distance from 0, 0, and so is y. Now, if your center is not at the origin, we have to show that shifting here. So taking x minus h, and then also show the vertical shift of y minus k. So it says, write the standard equation for the circle with a center at 4, -1, and a radius of 3. So we have this equation down here. We're going to use this bottom one. So it's going to be y equals, or actually, x minus, and then h is 4, and k is a -1. So x minus 4 squared plus y subtracting a -1 squared equals 3 squared, because that's the radius. So it's x minus 4, the quantity squared, plus y plus 1, the quantity squared, equals 9. is the simplified equation for the circle. Example 5 says, write the standard equation for the circle with center at 3, -1, and containing the point 0, 2. Okay, so we don't know the radius, but we do know the center. And we know the point. So the point is 0, 2. So x is 0. So 0 subtracting h, which is 3 squared, plus y is 2. Oops. Subtracting a -1 squared equals r squared. We have to find r first. This was a boo-boo. So this is a -3 squared plus 3 squared equals r squared. So we have 9 plus 9 equals r squared. So 18 equals r squared. And 18 does not have a perfect square, but it is the square root of 9 times the square root of 2 for r. And the square root of 9 is 3. So the radians is 3 times the square root of 2. So we can write it in standard form by saying x minus h, which is 3 squared, plus y minus, or y plus, because y minus a -1 squared equals r squared. And then this simplifies to x minus 3 squared plus y plus 1 squared equals, and 3 times the square root of 2 squared is back to the 18. So this is the standard equation, which we were not given the radius. We had to find it using a given point and the center. No. The general form of the equation of a circle. If you were to expand or multiply out the standard form of a circle and rearrange the terms, you would get what is called the general form. So if we were to multiply this out, it would be x minus 4 squared, which is x minus 4 times x minus 4, which is x squared minus 8x plus 16. And then we would have to do the same with the y plus 1. And that's what they're showing here. That we would have an x squared, a y squared, and then we have the like terms on x, the like terms on y, and then the constants would get added together to make f. And the like terms on x are just a -2 of whatever h is. And the like terms on y are just -2 whatever k is. And then f is h squared plus k squared minus the radius squared. So if you are given an equation in general form, you can use what is called completing the square to rewrite the equation in standard form. The idea is to create a trinomial that factors into a perfect square. So going back to factoring, what you really learned in your intermediate algebra course, if we have this trinomial here, it's a perfect square because 3 squares to make 9, but it also 3 plus 3 adds to make 6. So perfect square is the same number being squared, or x plus 3 times x plus 3. So it says, so if you were given the following and wanted to complete the square, I want to have something that I can square, a perfect square. So here, if we took 6 and divided by 2, we get 3. And 9, the square root of 9 is 3. So let's take a negative 10 and divide by 2. That would be a minus 5. A minus 5 squared is 25. So if you take negative 10 and divide by 2, it's a negative 5, and the square root of 25 can be a negative 5. So in general, if the expression is of the form x squared plus bx, you can add c, which is really just b divided by 2 squared. So whatever your b coefficient is, you're going to divide by 2 and then square that. If you add that, that will create a perfect square. You can see below a few examples. X squared plus 10x. So we take 10 divided by 2 is 5 and square that is 25. So this is my perfect square. If you have y squared minus 8y, if you take a negative 8 and divide by 2, you get a negative 4 squared, which is 16. So if you add 16, then this will factor into y minus 4, the quantity squared. So whatever your b divided by 2 is, that's going to be your perfect square. So the third one is x squared plus 3x. If you take 3 and divide by 2, is 3 halves. So your perfect square is x plus 3 halves squared. And if you multiply that out, that's why you're adding the 9 over 4. So in general, whatever your b is, you're adding a b over 2 squared. So you definitely take some practice. So we want to complete the square. So b is equal to a negative 10. So we're going to take a negative, we want to divide by 2. So we get a negative 5. And so we have x squared minus 10x plus a negative 5 squared is x squared minus 10x plus 25. And that is the perfect square of x minus 5 squared. So examples 7 and 8 are kind of putting this all together with the equation of a circle and completing the square. It says, write the equation of the circle in standard form. Find the coordinates of the center of the circle and its radius. So let's regroup everything here so that we can get our x's together. So I've got x squared plus 2x. So I have to add something to create a perfect square in the x's. And then I have y squared minus 6y, and I have to add something to create a perfect square on the y. And then we'll have to subtract 6 equals 0. Okay, so if I take 2 and divide that by 2 and square it, I get 1 squared, which is 1. So I just have to add 1. And then here, if I take a negative 6 and divide it by 2 and square it, it's a negative 3 squared is 9. So I'm adding 9 here. So I have to circle what I'm adding. So I've got a 9 and a 9. So I added 10. So I have to add 10 to the left as well, or to the right as well. Because whatever I'm adding, I have to even it out. So now the x's is a perfect square of x plus 1 squared plus the y's are y minus 3 squared, because it's whatever came out of this. And then I'm going to add the 6 to both sides so that my constant's over here. So then I have 16. So 16 is my r squared. So my radius is equal to 4, the square root of 16. And this is really, h is a negative 1. So h and K, my center is at a -1. Oops, let me write it. -1 comma +3. Because it's always subtracting your H and K. So subtracting H is a -1, and subtracting K is just 3. So my center is at a -1, 3. Okay, so write the equation of the circle in standard form. Okay, so we have to regroup them again. So we have x squared plus 8x plus something to make that a perfect square, plus y squared minus 2y plus something to make that a perfect square, plus 8 equals 0. So this is gonna, oops, so this is gonna be 8 divided by 2 squared, or 4 squared is 16. So the 4 is my perfect square. It's gonna be x plus 4 squared. But I have to write what I'm actually adding, which is 16. Because I have to add it to the right as well. And then I have to take my -2 and divide by 2 and square that. So that's a -1 squared is 1. So this is going to be plus my y is y minus 1 squared. But I have to mark that I added 1. I added 16 and I added 1. So that means, and then we have plus 8 equals 17. But I'm going to subtract 8 and move it over here. So that'll really be 9. And this can be written as x subtracting a -4 squared plus y minus 1 squared. So we can see that my vertex is at a -4 and a 1, and my radius is equal to 3. The square root of 9 there, so 3. So you need to regroup and then complete the square and the x's. And complete the square on y's. And add to both sides. You're completing of the square. And then you're going to rewrite in standard form. So you may have to watch this video, especially the ending here, a couple times, just to kind of walk you through a couple other problems. Reach out if you have any questions at all, or stop by my office hours for help.